Sometimes when we're working with systems of two equations, we get kind of weird answers. Some strange things happen. If we have a system of equation that has no solution, that is said to be an inconsistent system. We would recognize that if we were graphing by getting parallel lines, they would have nothing in common. But if we're not graphing it, we don't see that visual cue, then we have to have another way to recognize it. And the way we're going to recognize it is that all the variables drop out. Okay, no more variables in the equation. We're left with all numbers, and the problem is that the numbers produce a false equation. We get something like 0 equals 10 or -5 equals 4. Doesn't matter what the numbers are. The point is that it's a false equation. If I have a system of equation that has infinite solutions, we call that a dependent system. Graphically, we would see two lines, one on top of the other. They're actually the same line. If we don't have that, then we would look for a different indicator, and that would be, again, all the variables dropping out, but we get something like this, 0 equals 0. The numbers are not important. The important part is that it's a true equation. So if your variables drop out and it's false, that's bad, no solution. If your variables drop out but what results is true, then it's good. You get lots of solutions, that infinite system. So let's look at two cases here. This first one, I'm going to solve this by additional elimination because it really wouldn't even be easy to solve for one of those variables, would it? We'd have to divide and get fractions. So the trick was flip these two numbers. So instead of a 2 and a 3, we're going to put the 3 and the 2, and then we tweak the signs as needed so that we get opposites. So positive on top, and then this will give me a negative for this one. Taking the 3, distribute it all the way down the line, 6x plus 18y equals 21. Same thing with the -2, distribute it all the way across, -6x minus 18y equals -20. When you add, the x's actually cancel, the y's also cancel, so we have to put a big fat 0 here, and then on this side we get a positive 1. Well, there's no variables and what resulted was false. That's bad. That means there's no solution, or we have an inconsistent system. Okay, so for this equation, what would we do? Well, if I want to get rid of my y's, maybe, I'm going to flip-flop those numbers, the 1 and the 5, and put the 5 up here and the 1 down here. Well, I didn't even write it because it doesn't really change the equation. And up here I made it a -5 because these need to end up being opposite when I'm done. So taking -5 all the way through, we're going to get -15x plus 5y equals the -10. In our second equation, we didn't really change. Adding the x's and y's both eliminate, we get a 0. And on the right hand side, this time it also gets eliminated and leaves me with a 0. So what I have is something that's true, which means I have infinite solutions, also called that dependent system.